to focus specifically now how polygons move on coordinate planes. This is called translation, reflection, rotation, and dilations. Translation, reflections, rotations, and dilations. Please make note of both the location that you are watching this video as well as the date and time. The date and time. Let's do a quick recap using our brain and hand techniques. Step 1, we're going to finger track and read out loud. Then we're going to highlight, underline, draw, label, and list, and solve. We are told that if a dam has a median of 360 feet, the top of the dam is 3 times longer than the bottom of the dam. Find the length of the top and the bottom of the dam. So we finger tracked, read, highlight, underline. Now we're going to draw, label, and list everything. So we have kind of a dam. So here's the mountainside. You should be able to visualize a dam is actually a form of a trapezoid. It's an upside-down trapezoid, or what you would perceive as an upside-down trapezoid. And we have a median here. Here's the word median. Median means we're connecting the midpoints. Median. And we're told that median is 360 feet. Make sure you label stuff and cross stuff out as you account for it. The top of the dam is 3 times as big as the bottom. We don't know the bottom, so we're going to call it X, which means the top is going to be 3 times X. We want to find the length of the top and the bottom of the dam. So our question is this: what is the length of top and bottom? Okay. So now we ask ourselves not what should we do to actually answer the question, but what can we find? What do we know about trapezoids? We learned that trapezoids have bases, which are top and bottom, and they're parallel. We also learned this simple equation. We learned that a median equals the average of the bases. Another way to express this is a median equals base plus base over 2. Let's use physical pickup and write this out. I'd like you to circle that median. Come over here, circle the median. Circle the word base. Circle base. Circle the other base, and plug it in, and it's over 2. Now we're going to go ahead and just collect like terms here before we cross multiply. It makes it a little bit easier, and of course we're going to get 360 over 1 equals 4x over 2. Cross multiply here. Actually, we don't need to cross multiply because the 2 goes in the 4. So we have 360, and then 2 goes into 4 twice, so we equal 2x. All we need to do here is divide by 2, and we find that our x equals 180. So this is 180. And then for the top, we're going to go 3 times 180. Rather than grabbing a calculator, let's do this math together. 3 times 100, 3 times 100 is 300. And then 3 times 80 is 240. You add them up, and we find that the top of the dam is 540. It's a good recap. Now let's talk about how we can make things move on the coordinate plane, including trapezoids. There's 4 things that we're going to be doing. They're called translation, reflection, rotation, and dilation. Now, you have seen these before. Translation is what we call a slide. That's where you just take one image and you're just going to slide it to the right. The way you mathematically translate things is if you have, let's say, an X and a Y, and you translate by, we'll call it A and B, whatever A and B is, then what's your resulting is going to be whatever your X and Y are, plus your A factor and your B factor. I'll pause and let you write that down. This won't make a lot of sense until we actually do this. Okay, so let's see how you can do this. Here we have an A, B, and C. Let's first find our coordinates here. And A is at 4 and over 4 and up 3. So we're going to go over 4, up 3. Our B is over 7 and down 1. And our C is over 2 and down 2. All right. Now let's see what we're translating by. We are translating by 6 units to the left. Now that's our A. Now since it's to the left, that's going to be a -6. And then 2 units down, that's our B. That means because we're going down, it's going to be -2. So there's a couple ways you can do this. What we're basically doing is we're taking each and every point and we're going to move it 6 units down, 6 units to the left. So A, we're going to go 1, 2, 3, 4, 5, 6. That's 6 units to the left, and then 2 units down. 1, 2. That's going to be what's called sub A. Now, if you look, your actual coordinates here are -2 and +1. So that's one way to do it, is to physically move each point. There's a little bit faster way if you know that all you're doing is you're adding, this is your A factor to X and your B factor to Y. So we can go here, we're going to take -6, and we're going to add -6, 4, technically that's going to be -6, and that's -2. Then here's 3, and we're going to -2. That gives us 1. Lo and behold, it's the same point. So let's do the same with both of these. We're going to translate by -6. So 7 minus 6 is going to give us +1. And then -1 minus 2 gives us -3. 2 minus 6 gives us -4, and -2 minus 2 gives us -4. So let's plot our other 2 points. Our sub B is going to be at +1, -3. That's our sub B. And then our sub C is going to be at -4 and -4. Close it up. And you can see it's the exact same triangle, but it has been shifted 6 units to the left, 1, 2, 3, 4, 5, 6, and 2 units down, 1, 2. That's called translation. So all we do is you add your A component to X, your B component, which is your vertical component, to Y, you slide it over, and you got it. That's translation. Next is reflection. Reflection. You're going to reflect over the y-axis. So imagine our y-axis here is a mirror. And you're going to take this image and you're simply going to flip it this way and get a mirrored image. So you can see here that if we take A and we're going to bring it over here, it's our X component shifts, but our Y component doesn't. So this seems counterintuitive, but if you have an x and a y, and we flip over the y-axis, all you do is you're going to opposite the x component and leave the y component alone. So to flip over the y, you simply opposite the x. Let's actually do this so you can see how it works. Again, our original components here are A is at 4 and 3, and B is at 7 and -1, and C is at +2, -2. So again, to flip over the y, we opposite just the x components. So we're going to go -4, 3, opposite, -7, -1, opposite, -2, -2. Let's plot those points and see what happens. -4, +3, that's our sub A. -7, -1, that's our sub B. -2, -2, that's our sub C. Close it up. Now you can see we have an exact mirrored image. It has simply been flipped over the y-axis. That's called reflection over the y-axis. You can also flip over the x-axis. Flip over the x-axis. And we noticed here that if we flip over the y, we opposite the x. If we have x and y and we want to flip over the x, we're going to opposite the y component. And that's going to flip us over the x. So you can see how those are related. To flip over the y, opposite the x. To flip over the x, opposite the y. So let's get these new components and see what we have here. Let's call this down here A, and that's going to be -8, -8. This is B here. That's going to be -6 and -4. And then C is going to be -2 and -6. So we're going to opposite the y to flip it over. So keep the x's the same. Now simply opposite the y component. So that's going to be 8, 4, and 6. Let's plot those new points. So sub A is going to be -8, +8. That's our sub A. Sub B is -6, +4. And sub C is going to be -2, +6. Close it up. You can see here that all we did is take this image and we flipped it over the x-axis. We flipped it over the x-axis by oppositing the y. Now rotation gets a little bit trickier. Rotation, there are 3 rotations we're going to learn. We're going to rotate 90 clockwise, rotate 90 counterclockwise, and then we're going to rotate 180. So if we're going to rotate 90 clockwise, we start, if you have x and y, clockwise. The easiest way to do this is first draw a clockwise arrow. Take the X and the Y. We're going to draw a little arrow like that. So how do you rotate? First you switch the X and the Y. So we have Y and X. And then we're going to opposite the one on the right. Notice the arrow here, clockwise. So to rotate 90 degrees, you do what I call switch and flip. Switch and flip. Switch and flip the signs. Switch and flip. So our original here is going to be, of course, we have 4 and 3. And then B again is 7 and negative 1. And C is at 2 and negative 2. Okay. Now, visually, just get a visual on where we're going with this. We're going to clockwise rotate 90 degrees. So from here, we're going to sweep around going clockwise this way, a corner, or 90 degrees. So just visually get that in your head. It'll help you understand your finished product here. So for our sub A, go ahead and make a template here. Now, since it's clockwise, draw yourself a little arrow like this. Draw your arrow here as well. That helps you remember the direction. So we're going to switch and flip. Switch and flip. So first we're going to switch. So we have 3 and 4, negative 1 and 7, and negative 2 and 2. We switched. Now we flip the signs on the right because it's clockwise. Follow that arrow. So we switch and flip. Switch and flip. Switch and flip. Let's graph that now. So we have positive 3, positive 3, and negative 4. That's going to be our new sub A. Positive 3 and negative 4. And then we have negative 1 and negative 7, which is going to be down here. That's our B. Sub B. And then negative 2, negative 2, that's our sub C. And close that up. So you look really carefully. So we've taken this and we've rotated it approximately 90 degrees. The easiest way to actually see you accomplish this, let's go from the origin. Draw an origin to B. Then from the origin, draw to sub B. Okay, and you can see from B to sub B, you've created 90 degrees. And we've created 90 degrees going clockwise. Counterclockwise is almost exactly the same thing, but you're changing what you flip. So let's start here. If you start with X and Y, to rotate, it's still switch and flip. Switch and flip for 90 degrees. So we take the X and the Y, but now if we do counterclockwise, counterclockwise goes around this way, to the left. So draw your little arrow like this. And what you're going to do is you're going to switch and flip. So you switch this time, Y and X, but now we're going to flip the sign on the first component. Why? Because that is our counterclockwise direction. Counterclockwise direction. Let's see how this works. Once again, our coordinates are here. We have 4 and 3. You should almost have these memorized by now. Okay, so to rotate 90 degrees counterclockwise. So just first get a visual. Counterclockwise means we're moving the triangle this way now. Counterclockwise. So step number 1 is we switch. So this is 3 and 4, -1 and 7, -2 and 2. And now draw your counterclockwise arrow. We're going to switch and flip the sign here on the left. Switch and flip the sign. Switch and flip the sign. Let's plot those new points and see what happens. Sub A is going to be -3, +4. That's sub A. Sub B is +1, right here. +7, way over here. That's sub B. And then C is +2, +2. Connect them. So we've rotated 90 degrees. Again, just to check to see that you have rotated, put a dot on the origin. Now connect to any point, B. Now connect to the same point after the rotation, which is B up here, or sub B. You can see, yes, that's 90 degrees, and yes, it was counterclockwise. That's how you can check. Our last one, we're going to rotate 180, but what's really easy about this is that rotating 180 and reflecting over the origin is exactly the same thing. What does that mean? So rotating 180 means I take exactly this and I go exactly halfway around. Well, you can see that's exactly the same thing as if I were to flip directly over the origin. Flip it this way over the origin. So for this, all you do is you take your X and your Y and you just opposite both. You don't switch and flip, you just flip the sign. So in this case, this is 4 and 3, 7 and -1, 2 and 2, 2 and -2. Make your templates. Now you simply opposite both signs. So it's -4, -3, -7, +1, -2, +2. Now we plot exactly those three. Here's B, and then we have -2, +2, there's C. So you see we have just flipped directly over the origin. Directly over the origin. So far we've done translation, reflection, rotation, and there's one more. Just as a quick recap, reflection over the origin is the same as rotating over the origin, and rotation by 180 degrees is the same. Last one is called dilation. Dilation means to make larger or smaller. Dilation means to make larger or smaller. When you have a picture on your smartphone and you take your fingers and you push it larger, or you shrink it back, that you are dilating the picture. And the mechanics, the computer programming that allows you to make those pictures larger and smaller on your phones actually uses the very basics of what we're learning here. So to dilate, we have what's called a K factor. K factor just means, are you making it bigger or smaller? And if you have X and Y and you dilate by what's called a K factor, all you do is you multiply. So we're going to do X times K and Y times K. And if your K factor is larger than 1, you're going to make it bigger. And if your K factor is less than 1, you're going to make it smaller. So let's do one dilation together and we'll be done. Says, draw the image of the following after a dilation centered at the origin with the scale factor of 5/3. So the scale factor is basically our K factor. And we have 5/3. We can see that 5/3 is bigger than 1, so we know mentally that we're going to make an enlargement of our original image. So our original image, we have basically 3 contact points. We'll call this contact point A, and A is at +9, +9. So we're going to go 9, 9. And B is at +6 and 9. And C is at, again, 9 again, and 6. That's our C. Let's take those 3 points down. We have A is at 9, 9. And B is at 6, 9. And C is at 9, 6. Now our K factor is 5/3, so here's our new points. Get your template ready. So our K factor, we're going to take 9 and we're going to times by 5/3 and get a new number there. Let me do this in the margin so it's a little bit easier to see. So we're going to go 9 times 5/3. Well, 3 goes into 9 3 times, and 3 times 5, our new point here is going to be 15. Draw another arrow. Times 5/3. 3 goes into 9 3 times. 3 times 5, and again, you get 15. So our new point, our subpoint A, is going to be 15 and 15. Let's try this one. We're going to go 6 times 5/3. 3 goes into 6 twice. 2 times 5. And that gives us 10. And then 9 times 5/3. We already did that earlier. 9 times 5/3 gives us 15. And for this, we're doing 9 times 5/3. 9 times 5/3 we already did. Again, gave us 15. And then we're doing 6 times 5/3. 3 goes into 6 twice, times 5. And of course, we're going to get 10 again. Now let's plot these points and see what we have. So we have 15 and 15 is our new point. So 15 and 15, that's our sub A. And our B is going to be at 10 and 15. And our C is going to be at 15, 10. you can see here that our new image is larger. It's larger by 5/3. We dilated our original image, which was this, by 5/3, and we got up here, this, right here. And we expected it to be larger because our K factor was greater than 1.